Okay, the first thing we're going to learn after the definitions is that the measure of a central angle is the same as the angular measure of its intercepted arc. That's really wordy. You'll see what I mean in a second. Really basic concept. Just to be clear, this is not a theorem. No one had to prove this to be true. This is just our convention of what we do. So angle YZX, let's get the letters right. YZX is 90. Let's put a little 90-degree symbol here, a box there. And UZV is 164. So this whole thing right here is 164 degrees. Pardon the bad handwriting. Find each of these. Before we go any further, let me just go ahead and read the sentence again and tell you what's happening. If this central angle is 90 degrees, then from the central angle, this arc right here, from Y to X or X to Y, is also going to be 90 degrees, which actually answers that right there. Just saying. Okay. The arc from V to U or U to V is the same as this central angle, so it's also 164. So 164 right there. So 164. And now we'll figure out all the other stuff we need to find. This is bugging me how bad my handwriting was, so I'm going to fix that. And so we have 164 right there. Okay, so let's find a few other things, and those other things are going to be pretty easy to find, and I'm going to tackle them in a slightly different way. Instead of reading this, I'm going to just go ahead and jump over here. If you have a straight line, then you have 180 degrees, right? Right. So this is 180 degrees. Well, 164 of it is taken up with this, so 164 subtracted from 180 is going to give me 16 degrees. So if this is 16 degrees, same thing here. They're called vertical angles. They don't have to be up and down, but they're across from each other. They're going to be the exact same. So this is also 16. And so I know if this is 16, then this is 16. We can also treat it like 180 degrees minus 164, same as that one. Oops, there you go. Now you can see. And I also know something else. This is also a right angle from XZU. That's a right angle. So I could do 90 minus 16, and that would give me, whoa, wrong color there. Sorry about that. That'd give me 74 degrees right here. So now I can identify all the other arcs, and we'll go from there. So this is a 74 degree arc. This is a 16-degree arc. This is a 16-degree arc. And the beautiful thing is, if I added 90, 16, 164, 16, and 74, I'd get 180. No, 360. Whoa, sorry about that. Yeah, 360. Sorry, I was thinking of a different theorem. Way off, my bad. And if I added the 90, the 16, the 164, the 16, and the 74, then I'd get 360 there as well. So let's actually answer the questions. The arc YXU goes from here to here. Well, that's a semicircle. That's half the circle. We know that because we've got this diameter going here through Z. So this is 180 degrees. You could waste your time by adding 90, 74, and 16, but it's 180. Okay, WU, we have established that to be 16 degrees. And XUV, ooh, we have a major arc here. Major arcs cover more than half the circle. So it's from X all the way around to U. Now you might say, well, why didn't you list the W? You don't have to list all the points in between that are listed, or that are labeled. X to U to V is 74 plus 16 plus 164. This is 90, by the way, but we've already established that. I'm going to write it the long way, though. 74 degrees, 16 degrees, and 164 degrees. And that's going to give me 90 plus 164. That is going to give me 224 degrees. I'm going to be highly embarrassed if that's incorrect. So 90 plus, yeah, that's right. 224 degrees.